So we are going to start with our MapReduce now. So in this module, we will talk about what all are the use cases where MapReduce is used. What is the difference between traditional way of computing and how does MapReduce change the paradigm? Look at the Hadoop 2x MapReduce architecture and the components, understand the flow of your MapReduce execution, implement the basic concepts and run a MapReduce program. So let's start with MapReduce. Okay. So when we talk about MapReduce, the only way how we can get to the data that is there in HDFS primarily is through MapReduce. MapReduce is a programming framework through which you will analyze it. Okay, no problem, Nagendra, that's okay. So if you want to talk about MapReduce, you will have to go through the white paper. So I would say that if you go down to the MapReduce white paper that was published by Google John Dean in the year 2004, that is one of the best information what you will get. So my suggestion is to really look at this PDF, look at what they're talking about, and it is absolutely fabulous. That will give you a very good idea about how MapReduce works. Okay, so that's the whole idea about how it would work. Let me close this. And if you look at the slide, what do we do in the weather data? You can find out the maximum temperature recorded in a year. You can prove how global warming is really happening. So these are the things where analysis of information via MapReduce would be good. If you talk about the healthcare domain, the problem statement would be, how do I remove the personal health information? Because every equipment would have some or the other personal information. So for analysis, I would want to remove the personal information from the de-identify or remove the personal health information. So these are some of the areas where MapReduce is going to be used. So let's see in a traditional way. Okay, without MapReduce coming up, how were we doing it? You had huge amount of data. Okay, somebody had to split that data into small chunks. So you had to write a Java code who will split the data into small chunks. Okay, then you will have to look at every record and grep that record. Grep is a Linux command which is for selecting, and then you will have to match that record, and finally you will have to store all the matches into one common location. So this was pretty time consuming and it was very difficult. So what does the framework do is, framework will allow you to split the data into 128 MB chunks using the framework. Then within each chunk, you have got something called as input split. I hope you are clear on this, guys. Block split versus input split. You would have an input split. You will analyze each of the input splits, and all of these things are happening in parallel. You don't have to write a code. There is a framework called as MapReduce which will allow you to do all of these things, so that you will only have to write your map and your reduce logic. Okay, so you have got big amount of data. You will have to split the data into each individual record. You will have to grab the record. You will get the output from each individual record. Somebody will have to bring together all that records, and this will be happening parallelly on two machines, and then we'll have it. Okay, so this is how we were doing it in a traditional way. You have got big amount of data. You will split it, you will grep it, you will match it, and then you will go ahead and you will get it. So you have to write everything on your own if the framework was not there. Okay, let's go to the next slide. So if you talk about the MapReduce framework, see over here, the MapReduce framework will help you in splitting the data. Okay, based on what? If I may ask, how you identify a record in MapReduce? Which class identifies a record in MapReduce? It should be a simple thing, input format. And then you will have a record reader which will convert it into a key value. It will go to the mapper. In the mapper, you will do something. You will pick up whatever you want. So let's take the example of this file that we spoke about, the transaction file. So let's say you want the sum of sales in Florida. Okay. In the map, what all are the columns that you're interested in? What does the input format do? It'll give me one record for me. Okay. And then it'll go to the map function. In the map function, what should I do? Which are the columns I'm interested in? This has got 9 columns. There is a transaction ID, there is a date, there's a customer ID, there is an amount, there is a primary product, there is a secondary product, there's a city, there's a state, and there is cash or credit. Which all are the columns that am I interested in the map? You will have the state column and the amount column, right? So depending upon your analysis, you will pick up whatever you want from the state column and from the amount column. That's exactly what you're going to do in the map. So the key value can be a singular key value, scalar key value, or it can be a composite key value also. So supposing I want to have the sum of sales of jumping category in Florida. So I would need a composite thing, right? I need jumping, I need sum, and I need Florida. So you will have to you have a use case, or you will have to write the logic for identifying what is the key and the value. So this is the way how you will think of an analysis. So in the map, you will go ahead and you will identify what you want. That will go to the reduce, and then it will throw out everything. So this is the MapReduce way. So now, why MapReduce? Okay, so remember we said about moving data to code and moving code to data, right? We have also covered the concept of rack awareness. Got it? So the biggest advantage of MapReduce is its ability to take processing to the data so that the data gets processed in parallel. Okay, so what are we trying to show over here is this particular block is processed by this particular map task. That's what we are trying to show over here. So you will have your processing that will go down to each individual node and it will try to analyze it. Okay, so you will send the code to the data. So that is how it happens in parallel, and that's the way how the whole thing would work, my dear friends. Okay, perfect. So if you're trying to solve a problem with MapReduce, this is the way how it will be. So we are trying to talk about the healthcare world. So in the healthcare world, all of your details would be there in your relational data store. Okay, you would use Scoop so that you will take a database dump in a comma separated value file and push it into HDFS. What do you want to push it into HDFS? You can do some pre-processing also over here. That is what this matches means. If needed, you can do some pre-processing of data as to what you need to push into HDFS. Once the data is in HDFS, it will be split across multiple nodes. Then you will have a map function which will go down to each node where the blocks are. You will write a map logic. It will pick up whatever it wants from the functions. That will be written to somewhere, and then reduce will read from there. Reduce typically means aggregation. Where did the name map and reduce come from? It actually came from a programming language called as Lisp, L-I-S-P. Map and reduce are functional. No. Google actually created it, but then the MapReduce has come from the programming language called as Lisp, LISP, in which there is a map and a reduce function, and it is a type of a functional programming. In functional programming, you do not talk about the state. You will always talk about the behavior. Okay, so Lisp is a programming language from where it comes, and it's a type of functional programming. So after doing the reduce, the data will be stored back into HDFS. So what am I trying to say over here is the input data is going to be in HDFS, and the output data will also be there in HDFS. Okay, so see over here, guys, this is what is the architecture. So the client will send across a request for accessing something. So see over here, this is the way how the whole process is going to work. So here you've got a client. I'm going to explain to you how the MapReduce process would work over here. You've got a client, you've got a name node, that's a master, you've got two data nodes. On the name node, you will have your resource manager. The two parts of the resource manager would be an applications manager and a capacity scheduler. On every node, you will have a container. There are two types of containers. There could be a map container, there could be a reduce container, and there could be an application master container. Okay. So let me give you an example over here so that this becomes clear for you. Let me remove this before I actually move on. Yes, even SAP has got it connected to Hadoop. So there we go. So what do we have? We have got a resource manager. Before even we look at the diagram, I want the concepts to be clear. The resource manager will be there on the master. You will have a node manager which will be there on every slave. The resource manager will have your applications manager who is responsible for starting the application master on a node for every job. Okay. Plus it will have the capacity scheduler. Okay. Then the node manager will be there on every slave. Every slave will also have a container. Container is nothing but a JVM where the map and reduce tasks would be executed, and it will also have a container which is a JVM where the application master would be running. Okay, and if this is clear, we can easily go ahead and understand the architecture. The architecture is very important for you to understand. So what is node manager? Hey, every slave will have a component for coordination called as node manager. It was called as task tracker in the earlier version. Okay. One JVM can contain a map or a reduce or a application master. It cannot contain everything. Okay. Application master is a component which takes care of the life cycle. Remember, what is the disadvantage of your Gen 1? You had to talk about the life cycle management. Job tracker was getting overloaded. So they broke it up into the resource management is taken care of by Yarn, and the life cycle management is taken care of by the application master. Got it? So let me minimize this. So see over here, the client would be talking to the resource manager because it is submitting a job. Okay. So the client will submit the job to the master because it needs to process it. If you still have a confusion, ask me, I'll help you. Then on the resource manager, who is the guy who will talk? On the resource manager, there will be an application manager who will start the application master on any of the nodes. Okay, who will take care of life cycle for that particular application. Okay, that particular application master will start the map task on the node wherever the data is. Remember, the processing has to start from the node wherever the data is. The reduce task can be created on the same node or it can be created on any other node also. Okay. Then for getting the resources, the application master will communicate with the resource manager for getting the resources. The node manager will also be communicating with the resource manager for getting the resources. And for checking the status of the work, the client will communicate with the application master for getting the status of the work, because the application master is going to talk about the life cycle of a job, guys. Okay. So just to make it a little bit more clear for you, let's say I have got a 10 node cluster and 5 node cluster should be enough. 1, 2, 3, 4, and 5. Okay, and I have got a file for 200 MB of data. So 200 MB means it will be broken down into 128 MB and it will be broken down into 72 MB. That's correct, right? So tell me, where will the map task be running? On which all nodes will the map task be running? It will be 1 and 3. On which all nodes will the reduce task be running, friends? It could be anywhere. Why not 1 and 3? It could be on any node, friends. That's the beauty. Okay? Because map is a separate process. Think of it like level 1 support and think of it like level 2 support. Okay? I'm just giving an example over here. So that's why I gave you the multi-node cluster, so that depending upon how many nodes are there, how many reduce things are there, reduce will be running, friend. Okay, Prakash? So guys, I hope you're clear on this diagram as to what the purpose is. Fantastic. Let's move on. So these are all the different components what we have in MapReduce. I have just explained that to you. It's better to put that into a document. So client is a person who submits a MapReduce job. Resource manager is a cluster level resource manager, long life, high quality hardware. Node manager is one per node which monitors the resources on the node. He will interact with the resource manager for getting the resources. The capacity scheduler will also come into picture at that time. The job history server only maintains information about the submitted MapReduce jobs after their application master terminates. Okay, yesterday we had to start with our job history server. Application master is one per application, short life, coordinates and manages the MapReduce jobs, negotiates with the resource manager to schedule their tasks, and the tasks are started by the node managers. Container are created by the name node when requested. Okay, and allocates resources on every slave. Okay. Good, guys. So this is about the concepts. We are clear on this. So now you will actually be running a MapReduce application on Yarn. I'll be showing you how to do that. So everything is done by the resource availability on that particular node. So when we talk about a MapReduce job, there is a job submission. Remember yesterday we did Hadoop jar, the name of the jar, that's a job submission. There would be a job initializing that would happen. The individual task would be assigned on every node. The memory would be assigned. There would be a status update, that was communication call with application master, and there would be a failure recovery that will happen. If one of the nodes wherever the map runs fails, it will automatically be started on another node wherever the data is. Okay, cool. So here we are going to talk about the execution of a MapReduce flow. One, you have got a client JVM. Client is somebody who's outside the cluster. He would submit a job. So that is point number one. How does he submit a job? He will say Hadoop jar, the name of the jar file, and he would press enter. That is the way how a job is submitted. When the job is submitted, it would go down to the management node or the master node, that is the resource manager, to get the new application ID. Remember, the job ID comes in. Okay. As a part of step number 3, he would copy the job resources. Remember, we said moving the code to the data. The code has to go to the data, right? So it will copy the job resources to HDFS in step number 3, and then it will submit the code to the resource manager. So these are the first 4 steps. There are totally 12 steps. So guys, I hope you are clear on the first 4 steps. Whenever you say Hadoop jar, the name of the jar file, the name of the application, and press enter, a job gets executed, which will go down to the management node for the job ID. The job gets copied down to the HDFS, because only HDFS will know which nodes have the data, and then the job gets submitted to the resource manager. Okay. Let's get down to the next slide. So now, step number 5, the resource manager will ensure that you start the application master container. Okay, so it will tell the node manager to create the container on the data node itself. So that is step number 5. It will start the application manager container by telling the node manager to create the container. Okay, so once that is done, okay, step number 6, it will tell the node manager to, okay, that the arrow should have been the other way around. Okay, I think the create container arrow is what is this? Node manager telling to create the container, and then Step number 7, the application master will talk to the HDFS and will know the input splits wherever the data is, right? And it will tell the node manager to actually start the container for the map and the reduce. So that is taken care of by the app master. So that is what is the start container arrow that is showing. Plus, for any resources, he will have to talk to the resource manager for getting the data. And then you will see the node manager will actually start the container. That is step number 10. But before step number 10, step number 9 is the container would be started by the node manager. It will create that container on step number 10. The MapReduce task will actually go ahead and get the resources from the HDFS, and the execution would happen. These are the 12 steps that we have over here. What is submit application? Submit application is the command that you wrote, Hadoop jar, the name of the jar file. Okay, so all of these things happen when you run that particular command. So submit application means move that particular code or register that application to the resource manager. First, you say that you want to run a job. You will get the application ID, you copy the resources, you submit the application to the resource manager. Those are the first 4 steps. Okay, good. Velan said there are 2 start containers. Are they different? They are the same? No, they are different. The first start container is for the node manager to start the application master container, who is going to talk about the life cycle. And the second start container, create container, is for the node manager to start the actual container where the map and the reduce are going to start. So let me go up a little bit. I'll show you one slide before we had seen this. See over here, friends. There are 3 containers here, right? So there's a container for the application master. Then there is a container for the map and the reduce task, right? So the node manager will create the container for the application master, and the application master will tell the node manager to actually start the container for the map and the reduce. So those are the 2 separate steps that we have, friends. Let me go down to the actual slide now so that this becomes clear for you. Step number, this thing is 6 is node manager starting the container. There is application master. Okay, so think of this arrow that you see over here, friends. Okay, this arrow that you see, what is highlighted, that goes from the application master to the node manager. It should actually be the other way around. Okay, and then the application master will, in the step number 7, will get the input splits. He will ask the resource manager in step number 8, and step number 9, he will tell the node manager to start the container, and the node manager will start the container. That is your step number 10. The 11th, the MapReduce task will get the resources from HDFS, and the actual execution happens in the container. This is the complete end-to-end flow, guys. Okay, the client requests a job. Step number 1, I'm repeating the whole thing once again. It will talk to the name node for getting the job ID. The job ID will come back to the client. Client in step number 3 will copy the XML file and the jar file to HDFS. Then it will submit that application, whatever is needed, to the resource manager so that there will be a queue. So remember, only when you submit application will the capacity scheduler comes in over here, right? Then step number 5, the resource manager will tell, okay, I have to start with the application master for that job. So it will tell the node manager to create the application master on one of the nodes. Step number 7, the application master will get the input split from the HDFS. Okay, then he would know which all nodes the data is. It will tell the node manager on that machine, okay, to start with the container. So that is what is step number 9. It will also talk to the resource manager in step number 8 to get the resources. The node manager on different machines will start the map and the reduce task. That is step number 10. Each task will talk to HDFS to get the job resources, step number 11, and finally the map and the reduce gets executed. So remember, the application master is one container, separate JVM, and the map and the reduce is another JVM. So there are three slides, right? Let me go up. See, the first slide is basically the blue arrow. The second slide is basically the orange one, and the third slide is basically the red one. Okay, that's all. That's the reason why we did it. Good. So that was about our complete end-to-end execution. So if you look at the screen over here, you have got the resource manager. There are two parts, right? I told you applications manager and scheduler. The resource manager would, for the first job, create a container for the application master. Application master will tell the node manager on node, this, I don't know what, let's call it a 6. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, top down. So the application master on node 3 will tell the node manager on node 4 to start with the container, and also the container for in node number 5, because that's where the map task or the reduce task will be happening. Similarly, for the second job, it is there on my application master is on my node number 6, 8. And it will tell on node number 4, node number 10, and node number 12 to start with the containers. So this is the complete summary of the execution steps. Okay. So sequence is client submits an application to the resource manager. Okay. Then the resource manager allocates a container to start the application master. Clear, guys? Okay. Then the application master registers with the resource manager because he will have to talk to the resource manager for the resources. Okay. Then the application master asks containers from the resource manager. Why? Because I know where the data is going to be, right? Then it will tell the node manager to launch the containers. Okay. Then the application code is executed in a container. Okay. Then comes the status part of it. Client contacts the application master to monitor the application status. Guys, I hope this makes it very clear, guys. So this is the summary of your complete MapReduce workflow. And then once it's done, application master unregisters with the resource manager because I have finished with the job. Here comes Annie. So what's the answer for this, friends? Yarn was developed to overcome the following disadvantage of the MapReduce framework. I'm talking about the MapReduce framework. Okay. I'm not talking about the HDFS part of it. So single point of failure of the name node, that is HDFS part of it. Only one version can be run in a classic MapReduce. That's also correct in one way, because you will only be running only MapReduce. But then the primary reason is the job tracker overburden. Okay, so the answer is C, too much load on the job tracker. Who removes that load? Application master. Okay, the right answer to the earlier question is too much burden on the job tracker. The next question, in Yarn, the functionality of the job tracker has been replaced by which of the following Yarn? So has been replaced by which of the Yarn features? So what are the two things where a job tracker had a difficulty? Okay, so the job tracker was taking care of the life cycle of your job. Okay, plus it was taking care of the resource management part of it, right? These are the two things what a job tracker was doing. So this is more of a checkbox. There are two things. Okay. So the functionality of the job tracker has been done by two phases over here. It is basically the life cycle. Life cycle means what? Life cycle means the monitoring of the task, right? Not the scheduling of the job. So one is resource management. That's for sure. Most of you are correct. Resource management is correct. And the second one is your task monitoring. The job scheduling is taken care of by the framework, the capacity scheduler. Or there is also a scheduler called as FIFO scheduler. So it is actually two things, that is life cycle and the resource management. So see over here, This is what Annie had to say. So task monitoring, the fundamental idea of YARN was to split up the two functionalities of the job tracker, resource management and monitoring ideally, okay, into separate domains, and that's why this answer, okay. The task tracker is on the data node like a node manager which will actually execute the task in which there is a JVM. True, VLAN, but ideally the scheduling is by another component. In your earlier world, the scheduling was also, although they said slash scheduling, that is not the right answer, friend. The scheduling is actually done by the FIFO scheduler. Look over here. We have got a capacity scheduler and we have got an application master, right, friend? So there was also a scheduler in your Gento. Okay, I had given this comment to them earlier also that they should remove the word job scheduling. Okay, so the job scheduling is actually taken care of by the scheduler. So in YARN, which of the daemons takes care of the container and the resource utilization by the applications? Look at the word applications. Focus on the word applications over here so that your concepts will be clear. Who will take care of the container? That is your map and the reduce container and the resource utilizations by the applications. So this should be very clear. It is actually the application master. Okay, perfect. Can we run MapReduce jobs in a YARN enabled cluster? Yes or no? So there could be two questions. Can we run a MapReduce one as it is in a cluster? But that's not what I had asked here. I had asked, can we run? So the answer is yes, of course. But if the question would have been, can we run MapReduce job as it is in the Gento? It would be no, because you will have to recompile it. So the important point over here is, yes, you can of course run MapReduce Gen 1, but then, hey, what does it? These can be run on Gen without recompilation? Hey, when I say recompilation, the jar files needs to be done. It needs the jar files. You don't have to recompile, but then since the library files are different, although there is a binary compatibility, the jar files needs to be done, changed. Okay, because Gen 1 jar files are different, Gen 2 jar files are different. There we go. So which of the YARN or MapReduce 2 daemons are responsible for launching the task? What is actually the meaning of a task over here, guys? The map and the reduce containers. Okay, that is what is the meaning of a task over here. So who is responsible for launching the task, my dear friend? Good. Most of you have got it correct. Okay. Hey, launching the task, Koteshwara. Who is responsible for launching the map and the reduce task? He will talk to the resource manager, but then who will say that you have to actually launch it? Okay. So responsible for launching the task, not responsible for telling which task to launch. Okay. So the actual answer to this thing is the application master. So let's look at the complete life cycle. So now let's understand what is the complete flow. So there are 6 columns over here. The first is input. When I say input, I am referring to a block over here. Okay. So a file can have multiple blocks. Okay, and these things are going to be taken care of at every block level. So imagine my 200 MB file, I will have 128 MB and I will have 72 MB, right? So there are 2 input blocks that I'm having. The first phase is called as the splitting phase. Splitting phase means identifying a record. Okay. So splitting is looking at a block and converting that into records. Splitting is going to be taken care of by the input format, and after a record is identified, it is a record reader class which will convert that into a key value pair. Okay. So first is splitting, and then the record reader will convert that into a key value pair. Okay. What is the default splitting logic? /n or a new line. Okay, so now you will have, as a result of the splitting, you will have K1 and V1. Please note K1 is always the offset point. Okay. K1 is the cursor position in the file, which will always start from 0. Okay, good. So at mapping is a data stored somewhere. Remember, Velan, we had said earlier, the output of the mapper is stored and the node, and it is temporary till the time the job runs. After that, the job is, that data is ignored. Okay. How many maps and reducers? Let me copy that link and then we will have a look at it to see what are they talking about over here. There we go. Let me click on this wiki.apache. Let me click on enter again. I'm sure the slide is there. Okay. So see over here, number of maps. The number of maps is decided by the number of DFS block. We're talking about the map task. He is correct. Okay. But then what are we talking about over here? Within a map task, okay, within one block, you'll have multiple records, right? Within one block, you'll have multiple records. So one task will have to go through all the records inside that file, right? Exactly. So within a task, all the records are handled by the mapper sequentially. That's what happens, right? But then the beauty is parallelism. You can have multi-threading and all of that. So now each of the record will have to go through the mapper. So see here, each record has gone through the mapper and you will have your output of the mapper. So once the mapper has finished, then comes the shuffling logic. The shuffling logic is controlled by the application master. Okay. So what does the shuffling logic do is it will look at the key across all the nodes. Okay, and it will give those keys to each of the reducer, and so the output of the shuffling will be that you will get a key. Look at this, beer is there in the first output and beer is there in the third output. But after shuffling, all the values for the beers will come together. Okay, so that is what is taken care of by the application master. The shuffling process ensures that all the values of the similar key that is executed in multiple nodes are all brought together, like how you shuffle a card. Shuffling will ensure that all the values of the similar key are brought together and given to one reducer, and then the reducer will do the aggregation of it, and the output is going to be written in the HDFS. This is the whole thing. Okay. So shuffling will ensure that all the values across the nodes are brought together. Shuffling is controlled by the application master, and it is actually all the values are taken from the individual nodes and it is given to a reducer. So it is happening on the data nodes. Remember, map task will run only on one node wherever it is. And when I asked where will reduce run, you said it can run on any node, right? So that is what would happen. So each of the reducer tasks will be assigned one of the keys and they will do the reducing, and the output is stored into the final result. Okay. So this is the complete end-to-end process of a MapReduce, folks. So let's proceed ahead, guys. So let me go down to the next slide. There we go. So if you look at the anatomy of a MapReduce program, everything is going to be a key value. The key and the value in the map would be the offset point is the key and the record is the value. It will get converted into a list of K2 and V2 based on the business logic, whatever you have in the mapper. The shuffler will ensure that all the values for the same key are brought together. So the input to the reduce would be a key and a list of values, and the reduce will do the aggregation. That is what is the anatomy of a MapReduce program that we have seen. I hope all of you have worked with listen to the video. Okay, today we are going to see how it works.